oxygen in a compound. The tetra tells me there's 4, and the ox tells me it's oxygen. So 2 nitrogens, 4 oxygens. So that's the easy one. I will give you the table of the prefixes as well. Okay, so then we reviewed just a little bit on our core and valence electrons. The valence are the outer ones. This is the outermost shell, outermost electrons. So that's what is represented for our electron dot stuff. I actually have this listed twice then for the nomenclature stuff. So our fluorine. Let's go to the page. Number 9. So our electron shell stuff, 2 and then 7. So remember, these are the number in the filled orbitals, filled shells. First one only gets 2, next one gets 8. So that means my fluorine, if I write the electron dot structure for it, we put dots around that only represent the valence shell. These are the outermost electrons. So if I do calcium at 20, got 20 electrons, so that's 2 and 8 and 8, so that's 10, 18, and then 2. These guys are all filled. These are the core. We're only interested in the valence, the last shell, the one that is not filled. So that means for my calcium, my electron dot is calcium symbol with 2 dots to tell us it has 2 valence electrons. Okay, so I already said nomenclature. So you get a couple of these guys. So we can go from the formula to the name to the formula for ionic stuff and the covalent stuff. All right, that really should be down here under the covalent stuff. All right, so we've gone over naming ionic and covalent stuff. We have 2 types of acids. We can have hydrogen with just a nonmetal, and we can have hydrogen with an oxyanion. So this guy hydrobromic acid. Hydro, name of the nonmetal, and then ic and acid. This guy, we have hydrogen with one of our oxyanions, oxygen with a nonmetal. This one there's no hydro in front. So this is going to be nitric or nitrous if it's one less. Okay, so there's the 2 types of acids, 2 types of namings for our acids. And then the last thing is the shapes of the molecules. So this one would take too long if I made you derive the shape from it. So you do have to be able to apply the electron dot stuff. So a quick review of that guy. Let's say sulfur dioxide. My sulfur, 6 valence electrons. Each of the oxygens have 6. So 2 times 6 is 12 plus 6, 18. They both have 6 valence electrons because the oxygen and the sulfur are both 6 columns over. 1, 2, 3, 4, 5, 6. The oxygen's electron configuration is 2 and 6. He's number 8, of course. Sulfur is 16, so he is 2, 8, and 6. These are all filled, so they don't count, so that means both these guys get 6 valence electrons. Okay, so I stick sulfur at the center, oxygen's around them. I need to share electrons, so we have to have a covalent bond to hold our molecule together, so that's 2 and 2, so that's 4 electrons. I need to complete the octets of the outer guys, so that's 6 and 6, 12. So remember, we complete the octets of the outer elements first before we worry about the central. I have 2 electrons left over. They go on the central element. And then finally, we check to see if our central atom has an octet. So 2, 4, 6. He's missing 2. So that means I got to take one of these guys and make him share. So I'm going to pull 2 electrons off this guy and make him share. So that means in sulfur dioxide, the sulfur has a double bond with one of the oxygens, a single bond with the other guy. We have 2 bonding groups, and the number of bonding groups on the central element is just how many neighbors is he bonding with. That's the easiest way to figure that. However many elements around him, he has to have a bonding group with that element to hold the molecule together. And any pairs of electrons that are on the central atom, just the central atom, not the outer guys, the sulfur has 1 pair of electrons all to himself. That's a non-bonding pair for a total of 3. Okay, so
mine is 2, right?
yes,
So that would be 2.
he needs 8. Everybody needs 8. All the nonmetals need 8. That's our octet rule. Everybody has to have 8. The only exception to that is hydrogen, which needs 2. He's the only exception. All the other nonmetals have to have 8. So what we started with, the sulfur only had 6. So that means we got to make the outer element share 2 more electrons with it so that the sulfur can have 8. Okay, so I got 2 bonding, 1 non-bonding for a total of 3. You go look this up in that table that had the shapes, and we get a bent molecule for this guy. Okay, so that table, I will give you that. The table that has the shapes of the molecules based on the number of bonding and non-bonding, right?
So there's one. On that table, there's 2 places. One's for the cleaner and one's thin.
Okay, what page are you on? 194? Okay, we came up with 2 and 1. So I will give you this table. I need to find 2 and 1. Ah, look, they did it for us. There's our sulfur dioxide. 2 bonding, 1 non-bonding, for a total of 3. There's our sulfur dioxide, and it tells me the shape of the molecule is bent. So you look up
And stuff is,
Yes, you gotta look up the bonding and lone pairs for non-bonding. And the total, that gives you the total number of electron groups, but we're not really interested in that. We're just interested in what the shape is. So you look up the bonding, non-bonding, and that tells you what the shape is. So that would take too long to make you do the whole thing. So I will give you the electron dot structure for the molecule, and you've got to figure out what the shape is using that table. And you'll get one where you have to come up with the electron dot structure. So I'm going to break that up into two problems. One is the electron dot structure, and the other one is the shape. So you don't have to do the whole thing for one problem. Okay, so there is chapter 6. No real calculations in that guy. A lot more concepts. But 7 makes up for it, 7 and 8 make up for it. We have quite a few calculations in these guys. All right, so we talked about our molecular weights, formula weights. So this is our bold stuff. How many grams are in a bold? You're going to get a couple of these. One for a salt, one for a molecule. So of course, I want to know